Okay, this is geometry. This is chapter 8 review. It deals with similarity in polygons, similarity in triangles. First, what we're going to do is I'm going to go down a few of the problems that you probably might see from your textbook. And this comes from page 516. On 516, on 8.1, it talks about ratio and proportions and solving for x. Now you will have several problems that will deal with this. And what you have to do, I'll take an easy problem and show you. Then I'll take a more difficult problem. We'll go ahead. What I think might be one of the harder problems on it. And all right, so an easy problem I would think would be something like 3 over x equals 2 over 7. What we would do to solve for x is simply cross multiply and get 2x is equal to 21. Now, 2x and 21 obviously is going to be hard to, well, first we need to divide by 2 and divide that by 2, and x is equal to 21 over 2. Now, neither one of those problems have, they don't have any factors that would go into it. So I would suggest, and even on the test, let's just leave that in 21 over 2. Let's don't reduce it. Let's leave it in improper fraction form, especially for next chapter when we get into trigonometry and right triangles. Now, a harder problem, which still works out the same way, is we'll cross multiply. We'll have 2 and we'll have x plus 6 is equal to 4 and x plus 1. So you want to make sure before you do this that you set it up so that you don't forget to cross multiply. To distribute. Now you'll have 2x plus 12, and you'll have that equal to 4x plus 4. So now we want to get x by itself on the same side of the equation. So I'm going to go in and I'm going to just simply subtract 2x from both sides. And that's going to give me 12 is equal to 2x plus 4. All right, now we want to start isolating the x by itself. We're going to subtract 4 to move that over. That's going to give us 8 is equal to 2x. And then lastly, we're just going to divide both sides by 2. And that's going to give me 4 is equal to x. So the main objective in this is you do the same thing over and over again. You cross multiply and then you divide. Same thing over and over. Now, what is so important, though, about this is these proportions. Once you understand how to work that, that's the easy part. The hard part comes in when we start looking at some triangles and setting the triangles up so that we can prove or solve for x. Now, a couple examples of those, and this is on page 518, and this comes from section 8.6 and 8.5. But if you look, zoom in real quick. All right, when you have, a theorem that says when you have 3 lines that are parallel to each other and they're transversed by 2 different transversals, then they set up a very unique proportionality statement. We can say, just based on problem 18, we can say that y is to 7, and you want to stay on the same side. Y is to 7 as 15 is to 10. So the main thing is this is on the left side of the problem, the y minus 7. 15 minus 10 is on the right side. You want to keep y and 15 on top of your fractions and 7 and 10 on the bottom. Now, I'm going to go ahead with 15 and 10 and reduce that down because if I can reduce the fraction, I'm going to reduce it. So I'll have y over 7, and then over here I'll reduce both by 5, and that'll give me 3 halves. Then I'll cross multiply, which is what we're always going to do, cross multiply and divide. And when I cross multiply, I'm going to end up with 2y from the 2 times the y is equal to 21. Then I'm going to divide both sides by 2. Okay? And then that's going to leave me with y is equal to 21 over 2. Or you could even look at that as 10. 2 times 10 is 20, leaves you with 1 half, or 10.5 if you do it with a calculator. Either way works out. But basically now we have found the length of y in this problem 16 is 10.5. So 10.5 is to 7 as 15 is to 10. Another problem to look at would be on number 17. Several different things going on here. All right, we have this one is saying that we need to find. Let's see, where's my 17? Okay, there we are. Now we've got to find h. So they give us basically, we've got. If you look at it, we've really got three triangles here. We have this triangle, and then the large triangle. So several ways we can compare it. The way I would set it up is I would say, first of all, this triangle right here is h, and that's 24. And then we're going to compare it to this triangle is 35, and then whatever that is. So what I would do is I would say h, which is the bottom variable. H is to, now if this whole length is 40, and we know that's h, then the remaining side is going to be 40 minus h. And we're going to set that equal, and then we're going to say that h is to 40 minus h as 24 is to 35. Okay? So it should look something like that on your paper. H over 40 minus h is equal to 24 over 35. Now, we're going to go in and we need to cross, let's say 24 and 35. Can't really reduce those, so let's cross multiply. Let's say 35 h is equal to, and then we're going to have 24 times 40 minus h. All right, so now we've got to figure out what 24 times 40 is. 24 times 40 is 960. So we have 960 minus 24h, and we have 35h here. So now we want to, let's add 24h to both sides. That way we get the h's grouped together. And that's going to give me 59h is equal to 960. So now we'll divide both sides by 59. And h will equal 960 divided by 59 comes to be 16.27. And that's in decimal form. And our book has 16 and looks like 16 and 16/59, which comes out to 16.27. So that one worked out relatively easy for us. Now, you've also got several on the next page. You've got, this is a chapter test page, number 5, page 519. It covers 1 through 3, has some great solid proportions, and on down, especially with a problem of this nature, where it has 3 lines that are parallel. Now, the worksheets that we went over in class, I feel as though if you'll study that, a lot of your problems you'll see come from that, or really close to that. Lastly, I would look at possibly a bonus. Now, a bonus on this test would be something pretty easy, and it would just be the question that I put on your sheet today. And the question that was on your sheet was this. So this should be a very simple bonus. And it says, do you think that a person's age and the amount they eat each day are basically in proportion? Well, obviously we know that's not true, that how old someone is does not bear any weight on how much they eat. But tomorrow on the test, the bonus question, the answer to it that I want you to put would be that no, it's not the same, and I would like for you to say that it's more into what you eat each day, or the amount of calories that you take in is proportionate to your body weight slash metabolism. Because obviously somebody who has a, somebody who weighs a lot has to have more calories, especially somebody who has a higher metabolism has to have more calories. So really, and we probably just could say, we could scratch out body weight because that's probably not right. And let's just say that calories to metabolism. So the more calories you eat is in direct proportion to the metabolism that you have. So on the test tomorrow, make sure as your answer for the bonus you put no, and then you put calories over metabolism. That's how I know that you've watched this video. Good luck, and just study those sheets that we went over and the few problems that we looked at on the video, and you will do excellent. Thanks.